Welcome to the Math Practice Standards webinar series. This webinar will provide you information on the first mathematical practice standard, make sense of problems, and persevere in solving them. Although it's heady, let's start by reading this math practice standard in its entirety. Then we will unpack it piece by piece. Mathematically proficient students start by explaining to themselves the meaning of a problem and looking for entry points to its solution. They analyze givens, constraints, relationships, and goals. They make conjectures about the form and meaning of the solution and plan a solution pathway rather than simply jumping into a solution attempt. They consider analogous problems and try special cases and simpler forms of the original problem in order to gain insight into its solution. They monitor and evaluate their progress and change course if necessary. Older students might, depending on the context of the problem, transform algebraic expressions or change the viewing window on their graphing calculator to get the information they need. Mathematically proficient students can explain correspondences between equations, verbal descriptions, tables, and graphs, or draw diagrams of important features and relationships, graph data, and search for regularity or trends. Younger students might rely on using concrete objects or pictures to help conceptualize and solve a problem. Mathematically proficient students check their answers to problems using a different method, and they continually ask themselves, does this make sense? They can understand the approaches of others to solving complex problems and identify correspondences between different approaches. So as you can see, Math Practice 1 covers several habits that students should be proficient in. Let's break it down now into each section so we can fully understand each of these proficiencies. The first statement in this practice is all about getting started. The student should work to make sense of the problem. They should ask themselves, what is the problem specifically asking? What do I know? What am I trying to find out? Or simply, where should I begin? The goal is that students, without the answers from the teacher, are able to find their entry point and able to think about where to start in order to begin solving the problem. We all have those students that when asked, what's your plan, they just shout out multiply or divide without any understanding of why they would do that. This section claims that the proficient student actually develops a workable plan rather than just jumping to the first operation they can think of. Once the students have a plan, they put it into place, but they monitor as they implement the plan, constantly asking themselves, is this working? Does this seem correct? Should I try something else? They are willing to try different approaches when the problem is hard, or even try similar problems that are easier first. They also can rely on earlier, easier problems and try to make connections that would assist with the current problem. Math Practice 1 states that proficiency is the understanding of corresponding pictorial representations and graphs to the algorithms of the problems, like calculating slope using a graph or formula, or a much younger student being able to connect a picture of 3 apples and 2 oranges to represent 3 plus 2 equals 5. Now, once the students arrive at a solution, Math Practice 1 expects the student to ask themselves if their solution can possibly be correct. A proficient student will evaluate their solution and consider if the solution makes sense. And finally, Math Practice 1 states that math proficient students make connections. A proficient student could make the connection of unit rate to rate of change to slope. Students not proficient would see the concepts as 3 separated, unrelated ideas. So now that you have a clear understanding of what Math Practice 1 entails, let's move on to the implementation of this practice in the classroom. This will involve the necessary planning needed for authentic tasks and problems to be incorporated in the lesson design. When you plan, where do you normally begin? With the concept being taught, of course. Then you focus on the how. The math practices lend themselves to the how portion of planning. Teachers should plan rigorous problems or tasks as part of each and every concept. This forces the student to develop their own understanding beyond just repeating the notes that they may have written down as directed by the teacher. So what does this look like in the classroom? Problem solving. Students need to go above and beyond the odd numbers in the textbook. Communication. There is a plan for students to have time to discuss their solutions. And rigor. The tasks you provide for your students are at the level that requires them to justify and defend their solutions. I know we've all done it, but we also should recognize that true understanding is demonstrated through successfully solving those dreaded word and non-routine problems, so you have to deliberately plan for them. We must remember that problem solving and perseverance are not separate skill sets. These are not concepts that have standard numbers and letters and will be assessed on the next standardized test. They are habits of mind. They are actions that each student must execute to answer each of the questions on that next test. But you can't expect a student to suddenly develop these habits on the day of the assessment. They have to practice them routinely, just like they have to practice driving, making their beds, or anything to be good at it. The math practices should not be afterthoughts, but should be tied to the teaching of mathematics daily in all K-12 lesson designs. Since 2000, NCTM, the National Council of Teachers of Mathematics, has been asking for classes to be turned into problem-solving environments where students are supported so they can be successful. We've gotten better at providing more problems and tasks, but still in so many of our classrooms, the students are not experiencing success. As soon as many see a word problem of any sort, they tend to check out or think, I'm not going to be able to solve it. This creates that lack of perseverance. We need to provide environments where students are encouraged and taught to persevere. Students need to experience success with problem solving, and they need to experience repeated successes. That building of success is what continues their motivation and keeps them going. When we do something and we're successful at it, it keeps us wanting to come back and to try again. They are the same way. But do they have the opportunity on a regular basis? Students do if teachers plan for those experiences. As we plan, we should consider the questions that we will ask our students, the questions that we expect the students to ask of themselves, but most importantly, we should ask questions of ourselves. How many of our plans have stated page 16 even, or adding fractions, work text page 45? I know we know how to deliver the concept, and it's easy enough to check if they can reproduce the process, but does that create the habits of mind to problem solve and persevere? Questions we should ask ourselves are, did I select engaging problems and tasks? Did I allow the students to use mathematical reasoning and academic vocabulary as they worked and demonstrated understanding? While planning, the teacher's role includes putting the proper structures into place. They also must train the students how to explain and verify using mathematical vocabulary. Teach them how to be active listeners and work collaboratively. Then select engaging tasks that they want to complete. As you design your student experiences, you should constantly be asking yourself if you are doing what it takes to create problem solvers who can persevere. Here are some reminders as you design your student experiences. These questions will lead to more thoughtful lessons. Do the activities and discussions in my classroom focus on students thinking how and why a particular strategy was used instead of just getting the right answer? Do I use rich tasks that allow multiple entry points and solutions, or do I provide more simple and direct problems? Do I focus on 1 to 2 problems for students to solve and discuss thoroughly, or just provide a worksheet of problems to solve? Do I focus on tricks, such as keywords, that focus on memorization and can often be unreliable, or conceptual understanding? As we get better at asking ourselves questions during planning, we need to train the students to ask themselves questions too. Training should begin at a very young age and should continue throughout their math career. As teachers, we should ask the students these questions as they are engaged in the tasks, but the emphasis is on the fact that we want to help them develop the habit to ask themselves these questions. Perhaps in the beginning we could create an anchor chart or tape a small version to their desks. Here are some questions students should begin to ask themselves. What do I know about this problem? Can I explain the problem to myself or others? What strategy do I think will work? Where can I start? Did that work? If not, what else can I try instead of giving up? Does my answer make sense? How do I know? And how is my answer like others? Are there different ways to solve this? So now let's get more specific about the types of activities and tasks that it takes to provide the desired problem-solving experiences. We're going to look at a few tasks to see how mathematical practice 1 can be used. Consider this question. What is 1/2 times 1/4? This is a standard question that would appear in any textbook or on any worksheet. But what does it evaluate? If a student can multiply fractions? Or does it evaluate if the student can reproduce the process of multiplying fractions? If a student answers 1/8, what does that really tell you? Do you know if the student understands which numbers represent the numerator or the denominator? Does the student understand that 1/8 is actually 1/2 of 1/4? That 1/4 had been cut into 2 equal pieces? Odds are no. Most students can answer 1/8, but have no depth of understanding of what the algorithm really means. But consider this question. Create a picture that represents 1/2 times 1/4. Summarize how your picture represents the product of these two fractions. Can you see how this problem-solving task is much deeper than the previous one? It provides a platform for many different approaches to the same solution of 1/8. But now each of the fractions has meaning. Consider the academic discussion, the different entry points. What is 1/2? 1/2 of what? 1/8 of what? Are you sure? Looking at a sample solution to the revised problem, we can see the depth of understanding. This new style of problem prohibits a student from just multiplying the top and multiplying the bottom. It calls for explanation, justification, and pictorial representation. It's not easy. Pose this question in your next math planning session. Would every teacher do the same thing? How many would be immediately frustrated and want to give up? These types of questions do take more time, but they are so worth it in the long run. And now look what we can do. Same fractions, 1/2 and 1/4, only reversed. Create a picture that represents 1/4 times 1/2. Summarize how your picture represents the product of these two fractions. This demonstrates the communicative property and deepens the understanding that although the communicative property provides the same value, it does not provide the same picture or reality. And students will find this easier than the first problem after the first one had been discussed. Now they are more likely to find success. Real understanding of multiplying fractions will quickly develop after exposing the students to these types of engaging, rigorous tasks. And as a bonus, these types of tasks lead to the development of problem solvers with perseverance. Let's consider this question. There are 24 legs on the farm. Some belong to pigs and some to chickens. Find possible combination of pigs and chickens that could be on the farm. Thinking about the questions that students should be asking themselves, how would they answer for each? Possible student thoughts are represented here in red. What do I know about this problem? Okay, I know there's 24 legs, there's pigs, and there's chickens. Can I explain the problem to myself or others? I know that it's a combination of chickens and pigs that make 24 legs. What strategy do I think will work and where can I start? A student may reply, I'm going to start with 2 pigs and then count how many sets of 2s I have left. Did that work? If not, what else can I try instead of giving up? 2 pigs equals 8 legs. 24 minus 8 equals 16. So there are 8 chickens because they have 2 legs each. Does my answer make sense? How do I know? Lots of ways to do this. All are 24 legs. How is my answer like others? Are there different ways to solve this? There are many different ways. See how this type of problem makes for multiple entry points? Now, could this work with introducing equations with multiple variables? What other concepts could this apply to? What if we added constraints, such as there were 4 pigs, how many chickens must there be, create and solve the equation? These problems lend themselves to many options and to discussion. Consider this equation. Solve the equation 2.4 plus 4.2x equals 61.20. Most 7th graders can easily solve this, but are they problem solvers? Do they understand what a variable really is? Even if they understand the word constant, what do they really know? Now consider how engaging and rigorous this problem really is, and it's the exact same question as on the previous slide. James went to the boogie ball. It was being held 15 miles from his home. He called the Orlando Diamond Cab Company for a ride to the venue. How much did his ride cost? Create an equation to represent his trip. Create an expression using M for miles to represent how much the Diamond Cab Company charges its passengers. Upon internet research, the students will discover that the first mile is $2.40, which is the constant, and each consecutive mile is $4.20. As they engage this problem, they will calculate the total price. But there is an additional rigor to this problem that isn't in the simple solve this equation. If the students persevere and answer the third part of the question, they discover that the generic expression includes $4.20 times m minus 1, because the first mile is represented by the constant. Engaging in rigorous tasks require perseverance and depth of understanding occurs. Such tasks or problems as we have discussed take time and planning, but the payoff is huge. When students become problem solvers and can relate questions to the real world, they become proficient math students overall. Now we will conclude this webinar with a quick discussion on how we assess Math Practice 1. Students can be assessed informally during this process just by asking questions as you circulate. But some teachers want a more formal rubric or checklist. I suggest allowing the written portion of each task to guide your evaluation of the students' problem-solving habits. Did they provide a thorough explanation of their solution? This rubric can be used or adapted as a quick reference to assist with that assessment. Emerging students in Math Practice 1 will be able to explain their thought processes in solving a problem one way. Proficient students will be able to explain their thought processes in solving a problem and representing it several ways. And an exemplary student for Math Practice 1 will be able to discuss, explain, and demonstrate solving a problem with multiple representations and in multiple ways. It may be valuable to assess yourself too. This rubric is a great planning tool as you design your lessons, or just use it at the end of a unit. As you become more self-aware of the environment that you create, and if it's effective in implementing the math practices, you should see a direct impact on the problem-solving and perseverance habits of your students. So as we conclude this webinar, consider planning tasks that require students to find their own entry points and persevere in finding solutions. We hope this webinar helped clarify your understanding of Mathematical Practice 1, make sense of problems, and persevere in solving them.